In today's video, we will be discussing more about the different modules which are being added into DW 2.4 as a part of Mule runtime 4.4. So in our past videos, we have covered about dates and the periods module which are being added to DW 2.4. In this particular video, we will be talking more about the functions which are being added to the string class. Okay, so to start with, this is a sample project which I have created, and I am just drag drop this transform message onto the flow, and I will convert this to JSON, and I will also do one thing: import star from DW core strings. Now there are some new functions which are being added. So in order to check that, I have created some of the samples which I will refer from my notes. So the one which we are starting at the first level is count characters by. So let me copy paste these two examples. Let's put this in an array, and I will open the preview as well in parallel. Let's copy paste, and I will explain like how this is working. Let me adjust the screen as well. In the meanwhile, on the right hand side of it, you can see the preview. So what is this count characters by? So the first example is it is parsing through this entire string, and it is taking the count of characters which is numeric. Okay, so and it will give the number like how many counts or the how many characters are there which are matching this condition. So here is numeric, and it will count 1 2 3 4 5 6 and 7. So here you can see the count is showing as 7. Now for alphabetical characters, these are 3 and these are 5. So 3 plus 5 is 8. So in this manner, count characters by is working. It will give you the count of the characters depending upon the condition which you are mentioning. This is the first function which is being introduced in DW 2.4 string module. Let's go to the next. So collapse. Okay, so how does the collapse work is like whatever string you are giving as an input, it will create an array out of it based on the number of characters. So what I mean to say that A will be the first character or the first element. After that there is a space which will be considered as the second character, then the B as the third one, then again there is a space, that is this space, then B A. These two are considered as the separate one, B and A. But whenever there is a identical character like B and B, so these are being considered as a single object. It will not be broken down into the multiple parts. Okay, and then space is being considered, and then the last B. So basically what it does, it collapses the array of into the input string as into the form of an array. So you give an string, and as a result of this collapse method, an array is being returned back in which all the characters are being marked as its individual objects. Let's go to the next function, count matches. So count matches, like you just need to pass the string and the pattern, and then it will return the number of such occurrences. So if this is an input string and we want to find out the occurrence of an LO pattern, so LO1 is here and the second is this one, so that's why the count matches is showing as 2. The same thing can be implemented but in other DW function as well, which can get into somehow more complicated code, but if this thing is available, I would prefer to use this one on priority as compared to custom code. Now the next one is for every character. So let me try to explain you. So for every character, it will check if the value is equal to space or it is a numeric, but I am passing here the number, space, as well as a alphabetical character, right? So that's why it is returning as false. What if I remove a? Then it will return true. So this is checking for all the characters which are available in this particular string, and it will return back the result set in the form of boolean. It checks whether a condition is valid for every character in a string, and then accordingly the result set is being written back. Let's go to the next function. This is pretty much standard, you can say. First 5. So what does it mean? The first 5 character 1, 2, 3, 4 and 5. So that's why it is picking up the first 5. You can, if you mention 0, it will not give anything because it starts from H as the first position. What if you mention -1? Again the same thing because it starts with 1 and onwards. Let's go to the next one. I have already shown this first one as well. Hamming distance. So this is interesting. This is quite situational. Whenever if there is such need is such requirement is there in your coding, in your logic, then only it is useful. Otherwise it like rarely being used. It's like that sort of function, but you never know, depending upon the logic, if you require some this approach, maybe you can use this particular function of Hamming distance. So what does the Hamming distance means? Hamming distance take two inputs, first string and the second string, and then it compares each of the character wise. Okay, so just take this example. I will try to explain this. The first two characters are same. After that there is R and here is T. First variation, then there is O, then there H. Second variation, third variation is of L and R. Rest of the thing is IN, which is common in both. So there are three differences or three separate things which are differentiating in two strings. So that's why the result set is coming as 3. Now let's take the second example. K is common. Difference is starting with A and E. R is common. Then there is a difference between O and S. Then there is a difference of L and T. So in nutshell there are three variations, so that's why the result set is 3. Next example is of Catherine and Christine. So first difference is A and E, then T is there, but here there is R, 2 variations, then H and S, third variation, then R is there and here is T. So in total there are 4 variations, so that's why the result set is 4. Yeah, the next one is 4 zeros are there and there are 4 ones, so difference of 4 different variations are there, so that's why the result set is 4. Next one is, here is 1, here is 2, then 7, here is 3, then 3 and 3 is common, this 3 and this 3 is common, then 896, here is 796. So there are 3 variations and the result set of Hamming distance function will be 3. Quite simple, but again stating the same thing. Depending upon the logic, if required in your Dataweave, then only it will be useful. The next one is for last. So quite similar to the first, where we are using the last. So it will pick the last 6 characters. Okay, 1, 2, 3, 4, 5 and 6. So all these characters will count for 6 and the result set is coming as world with exclamation mark. The next function is of L-Evenstein distance. This is quite I would say it's quite on the same line as that of Hamming distance. So let's try to understand. This is a standard example of L-Evenstein distance. Even if you try to Google this particular thing, the first example will be of kitten and sitting only. Okay, because I have not used it in person for any of my specific logic, but it's good to know. Okay, we will try to see how we can make kitten to sitting. So how many changes we need to do. See, the first character is K and here is S. So first variation we need to make S to K. Then ITT is common, ITT is common. The rest is ING. So N is there, but we need to replace, we need to insert G and we have to replace I and N with EN. So again I am repeating. First variation is of K, then the last 3 for 10, in fact ITT is common, ITT is common. Now we have to work around with these 3 remaining. With first I and N needs to be replaced with E and N, second replace, and the G needs to be inserted. So that's why 3 is the result set coming out of it. Let me try to show you this example as well. I will take Wikipedia as a reference. So here you can see this kitten and sitting, the same example is being taken. So it takes K and substitution of S for K, then I is replaced for E, and last for G is for at the end. So that's why there are 3 edits are being required. Minimum 3 edits are required. So it is trying to explain that thing. I will mention this link as well in my description box and you can have a look around it. Again mentioning the same thing, these 2 particular example of Hamming distance and L-Evenstein distance, these are pretty much very specific. Most of the chances are there like you may even not require it, but it's good to know like there is such function available. So if you need any such logic, you can play around it. Let's go to the next function available. Let me quickly copy paste all these 3 first. Okay, because these 3 are quite on the same line. So result of lines. So basically line is a function which takes as an input of a string and converts it into the array. Okay, so hello world, this is being taken as the first line, then there is a line break. So here you can see the line break is there, then there is a space, and here Dataweave. So depending upon the line break, it is creating the number of lines, an array of words. in the form of lines. So basically the collection of words represent a line, so with that particular idea. Now the next one is for the words. Words is an example which returns an array of words from a particular string. So when I say words, an array of words means this is one word, this is second, this is third, and this is fourth. So here you can see as the output, it is an array of strings, individual words. Again, reverse, it will just reverse whatever you have mentioned as an input to this. So just printing the opposite, or the opposite order basically. Now let's take one more example. So remove function. So you have to mention two input. The first input is the input string, and the second one is the pattern which you want to remove from the string itself. So if you see, I have mentioned state two times, state here and stateful state. Okay, so if I want to remove the state, the output will become like this. Okay, similarly if you want to replace, wherever state is coming up with this particular string, it will replace all such occurrences. Okay, so the first occurrence for the purity, this state, and the second state full, so ful is coming up and the state is replaced by this particular string. Going to the next example. Yep, so it's a map string. Map string is one of the function in which it conditionally checks, and you can manipulate the values around it. It takes, yeah, just put your mouse pointer over here and it will show the entire definition of it. It converts the string to a map. So basically what it does, just an example, you have to pass as input string. Likewise I have mentioned as $1234 INR. Idea here is to mention numeric as well as alphabets in it. Okay, and I'm checking if there is an alphabet, then convert it into the percentage sign. Otherwise whatever is coming up, just mention the same thing. So dollar, this is being escaped character, so dollar will be taken as same as it is. It will not be considered in the condition mapping. Then 1234 is being mapped as the same, else part is following here, and then INR is there. So INR is fulfilling the first condition of is alpha, so it is being converted to 3 percentage signs. Okay, so this was just an example of map string. This could be useful in your logic as well. Let's go to the next one. So substring functions are there. Let me pick up all these. Okay, so the first substring is I am passing as hello world, and I want to break it down at the first and fifth position. Okay, so 1 2 3 4 5, right? So after 1 2 3 4 fifth position, so that's why it is giving this output. You have to specify 2 indexes basically. Now the next one is the substring. Let me try to adjust this. Okay, yeah, so this is a input string and we want to break it down if the string contains this particular sign, or whenever it has equal sign in it, or whenever it has underscore in it. So basically it will break it down at hello, then it will break it down world, then again it will break it down, then here break down, and then data and we will also be like break it down. So basically what I mean to say, so here you can see Dataweave and all the things are being substring based on this substring by function. and if there is hello world and vijay space in between, and if you can check like if the characters which we are reading through this particular string contains a space, then break it down. So hello and world substring by. The next one is for the substring every. So after every 2 position, break the input string and convert it into an array. So first 2, okay, then it will break it down, put double L, then there is space with an O within a space, then world, WORL, then D. After D there is no character available, even space is not there, so it will consider D as the only element available in the last interval. So what I mean to say, if there is this one, so it will consider D along with this, but if there is not in the multiple of 2, then it will consider whatever is present in the last available set. It will not error out. So with this I have tried to complete all the new functions which are being available in this module of strings. These are the new functions which are being added as a part of DW 2.4 as a part of Mule runtime 4.4 release. I hope you like this video and thanks for watching.